Okay, good day. This is Honors Algebra 2. I'm Mr. Cully, and this is the presentation for Section 8-6, Solving Rational Equations. This is the last section in this chapter, so let's get right to it. Today we are going to be solving rational equations, and that's fairly simple, but let's talk about the process for a moment. Let's talk about this process. The process for solving rational equations, you're going to multiply the entire equation by the LCM of the denominators to turn the rational equation into a polynomial equation. And then we are solving a polynomial that we've been solving those quite a bit this year. Once we've solved that polynomial equations, we're going to have to check our answers for extraneous roots. And the reason we're going to have to do that is because we're going to multiply this entire equation by the LCM of the denominators. And if that LCM includes a variable, then we have the possibility of adding a root, and we don't want to do that. So let's start with an easy one. And so when we look at this simple example here, I have these three denominators. I have three denominators. I have 3, I have x minus 5, and I have 12. So I want to find the LCM, the least common multiple of all of those values. Well, the least common multiple between 3 and 12 is 12. If I multiply 3 by 4, I'll get 12. That's pretty good. And so the only thing that would be missing is this x plus or x minus 5. So the LCM for these three denominators is just going to be 12 times x minus 5. And so what I'm going to do with this is well, let's just move this one down here. I am going to multiply this whole expression by the LCM 12 times x minus 5. Okay, now what's going to happen is since we multiplying by the LCM, every time you multiply by one of these fractions, this LCM is going to cancel out the entire denominator. Now there'll be stuff left over, don't get me wrong, there's going to be stuff left over, but we'll have no more fractions left. So when I go 19 times 12 times x minus 5, anyway. So when I multiply 12 times x minus 5, the 12 times x minus 5 times 19 over 12, the 12 is going to cancel. So I'll be left with 19, let's do it right. So I will be left with 19 times x minus 5. Now, when I distribute, I multiply 12 times x minus 5 times this fraction, 3 over x minus 5. The x minus 5's cancel, and I'll be left with negative 3 times 12, because that's what's left. And then when I multiply 7 over 3 times 12 times x minus 5, well, the 3's cancel, and I'll be left with a 4, and I'll be left with the x minus 5. So I have 7 times 4 times x minus 5. And again, we're going to have to distribute that eventually. But now this is just a polynomial expression. So 7 times 4 is 28. And then 28 times x, so I'll have 28x, and then 28 times 5. Well, let's grab our calculator and do that one real quick. 28 times 5 is 140. So I'll have 140 and then minus 3 times 12 is 36, and then we're going to distribute here. So we'll have 19x, and then 19 times 5. Let's just do that real quick. 19 times 5 gives us 95. So I'll have 95 there. So I have 28x, and then I'll have, let's see here, minus 176 equals 19x minus 95. So here I have distributed. Here I am just simplifying. And now here I am going, since I want to keep everything positive, I'm going to add 176 to both sides, and I'm going to subtract 19x from both sides. So when I add 176 to this side, that'll cancel that out, and I'll have negative 95 times positive 176. So negative 95 plus 176 gives me 81. So I've got 81 here. And then when I go 19 from 28, I'll have 9x. And so here I'm just going to divide by 9, and that'll give me x equals to 9. And since 9 does not make 3 over x minus 5 undefined, it is a valid solution. All right, next I have solved this equation. So we have x over 2x minus 1 plus 3 over x minus 4, and then we have this 2x squared plus 7x minus 4. Well, we're going to factor. We want to factor this first because we got to find the LCM. Factor 2x squared plus 7x minus 4. Okay, so we're going to do that. 2 times 4, 2 times negative 4 is going to be negative 8. And then I need two factors of negative 8 that add up to 7. Well, 8 plus negative 1 add up to 7. So we'll go 2x squared, and then we'll go plus 8x. We'll go minus 1x minus 4. And then I can factor a 2x from both terms, so I'll have 2x there, and then I'll have x plus 4, and then I can factor out a negative 1 from both of those terms, and we'll have x plus 4. And so my final factorization here is 2x minus 1, and then x plus 4. So the good news here is that the LCM of all three of these denominators is 2x minus 1 times x plus 4, which are these two values. So here's what we're going to do. We're going to take the original fraction, this this should be, so we're going to take this original fraction, and we're going to go x over 2x minus 1 plus 3 over x plus 4 equal to 221 over 2x squared plus 7x minus 4. And then we're going to multiply that by 2x minus 1 times x plus 4. Now, because this factorization is the same as this quadratic, when I distribute this factorization to this first fraction, it's going to cancel out the denominator and leave me with just 21. And then when I multiply 2x minus 1 times x plus 4 times this second fraction, 3 over x plus 4, the x plus 4s are going to cancel out, and I'll have 3 times 2x minus 1. And then when I multiply x over 2x minus 1 times 2x minus 1 times x minus 4, when I multiply that, the 2x minus 1s are going to cancel, and I'll have x times x plus 4. Now this is and we're still adding, so this is a polynomial, and so here I'm just going to simplify, and I suppose I should say that I am multiplying by the LCM. And so here I'm simplifying. So I've got x squared plus 4x plus 6x minus 3 equals to 21. So I'll have x squared plus 10x minus 3 equals to 21. Since it's a quadratic, I want to set this equal to 0, and I made a mistake. I made a copy error. Oh, that was bad. Let's see if I can do a better job. Made a copy error. Oh, darn it. All right. So here I want to simplify. Here I want to simplify. I'm going to have x squared plus 10x minus 3 equal to 21. And so we want to try and factor the quadratic. So we're going to set this thing equal to 0. So we got x squared plus 10x minus 24 equaling to 0. Now you can use a couple of different ways. You could either factor this or you could use the quadratic formula. But I need two factors of 24, one positive and one negative, that add up to 10. Positive 10 and positive 12 and negative 2, that'll work. So x plus, or x minus, or x plus 12, and then x minus 2. So positive 12 times negative 2 is negative 24, and then positive 12 and negative 2 is positive 10. So that's going to work. So my solutions here are going to be x equal to negative 12 and positive 2. Now I should go back up and check. All right, so negative 12. Does negative 12 make either of these equal to 0? Any of these equal to 0? Well, negative 12 certainly doesn't make that 0. Negative 12 doesn't make that 0. And if it doesn't make either of these 0, it won't make that one 0. Positive 2. 2 times 2 is 4 minus 1. That's not 0. And 2 plus 4 is 6. So that doesn't make that 0. So we are okay with these as our final answers for that one. Last one, example, Mr. McCulley is mixing a new hot sauce for his wild widgets. How many ounces of a 20% sauce must be added to 40 ounces of a 75% hot sauce to create a 30% hot sauce? Now, there are a number of ways to do mixture problems, and if you have learned a better way in the past to do this, I won't have a problem with you doing it the way that you know how to do it. But since this is a rational solving rational equations problem, we're going to do it in solving with rational equations. And so remember, when you're doing a percentage, it's the part over the total. All right, and so our goal here is to create a 30% hot sauce, and a 30% hot sauce would be 30 over 100. So that's our goal. And so what are we doing here? We already have 40 ounces, and we want to know how much we have to add. All right, so how many ounces of a 20% sauce do we have to add? So our X, that's what we're looking for, is ounces of, and these are fluid ounces, of 20% sauce. All right, so we already have 40 ounces of 75% sauce. So we have the part of that would be 40 times 0.75, and then to that we're going to add X ounces of the 20% sauce, 0.2, and then the total would be the actual, not the part that's hot, but the total that we're adding, which would just be 40 plus X. So again, it's part over total. And we want to, our goal is to get, so this is what we have. And so I'm going to simplify that a little bit. So I still have my 30 over 100, and then 40 times 0.75. So 3/4 of 40 is going to be 30. And then X times 0.2 is going to be 0.2X. And this will be over 40 plus X. All right. And again, a couple of different ways you could do that, but 30 divided by 100 is 0.3. And we got 30 plus 0.2x over 40 plus x. Here I'm going to multiply by this denominator, 40 plus x, which is kind of like what I did in the last one. And so when I do that, I'll get 40 plus x times 0.3 equals 30 plus 2x. So here I'm going to distribute. And so zero point 0.3 times 40 is going to be 12, and then 0.3 times x is going to be 0.3x. And so I'll have 30 plus, this should be 0.2. I left off a decimal there. So 0.2x. And so here I'm going to subtract 12 from both sides because I'm trying to keep it positive. And I'm going to subtract 0.2x from both sides. That'll give me 0.1x over here, and then 30 minus 12 will give me 18. I'm going to divide by 0.1. That'll give me x equals 180. And since 180 doesn't make this undefined, we're going to add 180 ounces of 0.2%, let's do it the way I had it. Ounces, OUNCES, of 20% hot sauce. And that is all I have for today, folks. So the McCully fun fact of the day, Mr. McCully played water polo as part of his fall high school sport. I was actually pretty good at it, much better water polo player than I was a swimmer, but water polo was not as big a sport. That's all I got for today, folks. Have a good day. Bye.